So welcome everyone to the first in a series of webinars to support your journey to include predictive maintenance within your company. Businesses across the world are embracing a more reliability-centered approach using condition-based monitoring and predictive maintenance strategies. I'm Brad Middleton, and I'm joined by leading experts in the field of enterprise asset management, Internet of Things and data science. Please welcome Sanna, Steve and Sven, who will provide their point of view on the maintenance strategies and methodologies.
So today I'm going to start by discussing the process and options around maintenance strategies and the different maintenance methods that could be considered within any good asset management practice. Firstly, there are a number of components that underpin any decisions that are made around the maintenance regimes that you choose. If we start at the bottom of this slide, business drivers and business objectives. So these could include things like reduction in safety-related incidents, reduction in operational or production losses caused by asset downtime, reduction in maintenance costs, improvements in asset performance, and improvements to first-time fix rates or mean time between failure. Secondly, we have some corporate or industry standards such as ISO 55001, ISO 55002, and some regulated industries may have more standards and regulations for the maintenance of specific asset classes. So therefore, these would need to be considered during this decision process. And then finally, the decision or the desire to move to a more reliability-centered maintenance approach, as Brad mentioned in the introduction. So what you can see on the screen basically are some of the specific methods that we could generally use around the maintenance of your asset base. All of the specific methods shown here, they're all viable options for maintenance of your assets. If we go from left to right, so run to fail, may be acceptable for non-safety critical or non-operationally critical assets. We have traditional planned and preventive maintenance, which is your traditional time-based or continuous meter-based inspections. So let's say based on run hours, for instance. And at times, these may be some of the ones that are actually defined by some regulation, so you can't avoid doing traditional time-based inspections on some assets. Condition-based maintenance, so these could be simple triggers based on near real-time data, where we're looking at breaches of thresholds, things like temperature or vibration, where the assets have gone out of their defined parameters. But you could also start to move into actions being taken on things like trend of data. So where the meters are actually showing a deterioration in performance. So it's a two thing. You can either do the real time when you exceed or go out of a threshold and trigger some event like a work order being created, or actually look at the trend of data to look for performance deterioration. Then we move on to predictive maintenance, where we use the metadata and also maintenance history of an asset using analytics to determine the predicted next failure date. In some cases, this is in relation to the projected next inspection date, so we can see if the asset's going to fail or predict if the asset's going to fail before you're next due to do, let's say, even a time-based inspection. And then finally, prescriptive maintenance. So this is where we can use analytics and also resources within your business, experts that have expert knowledge to assist newly trained resources. So next, we're showing here a swing from left to right, showing what we call an asset management maturity curve. I've seen this slide many times in many different presentations, and it is a very useful slide to see. I think the one thing to be aware here, though, is when you select any maintenance method for your assets, I think what's important to understand is that one size doesn't fit all. So it's unrealistic to set goals of changing all of your assets to use predictive or prescriptive maintenance, let's say. In the same way that it's, you would not want your entire strategy to run on a run to fail basis. So although this says it's a maturity curve going from left to right, I think, you're never going to have all of your assets that sit within one of these buckets. So generally speaking, you wouldn't normally be in one position on this curve. Because also not all assets within the same asset class would necessarily use the same method. So a motor that functions, for instance, on a production line conveyor is probably more critical to the business than, let's say, a motor that's running on a compressor that's used for some maintenance support purpose. So the key takeaway from this is that analysing an organisation's asset estate when you define your maintenance strategy, it will most certainly result in a blend of each of these maintenance methods. So you can see on here where we look at the bottom where you've got run to fail, which is an accepted risk and maintenance is an expense. But as I said, it's an accepted risk. Going through to where you try and then mitigate that risk. So you start to then look at, move into the condition-based and preventive maintenance, condition-based and predictive, and then prescriptive right at the far right. As I said, no company that I would be aware of would ever fit all of their assets into one of these columns. Slide 3 is really going back to the kind of different maintenance regimes, but at the bottom is showing some of the capabilities that are actually used to support each of these asset management maintenance strategies. So if we look at the bottom, we've got enterprise asset management. Essentially, that's going to run across the whole breadth of these. So that will cover all of the different maintenance regimes. You need a key underpinning enterprise asset management solution. Internet of Things. So this is where this starts to come into play around planned and preventative and condition based. And again, moves from left to right. Condition monitoring tools, they come along when we get to condition based. Predictive analytics. And then finally, some decision support tool to cover the prescriptive maintenance. And then finally, on the final slide for me, we just basically overlay at the bottom those capabilities with some of the IBM offerings within the Maximo portfolio. So enterprise and asset management, we have IBM Maximo, which is the core enterprise asset management solution. Following that, we have IBM Maximo Asset Monitor, which is where we start from an IoT platform, a connected assets perspective, and we start to look at connecting the data. Moving into, again, asset monitor still, but where we start to use more analytical functions around the condition-based maintenance and the trending of data and taking actions and insights from that data. Through to IBM Maximo Predict, which covers our predictive models. We'll be coming into some of this following sessions. And then finally, IBM Maximo Assist, which covers the prescriptive maintenance part of this process in connecting experts throughout your organization. So now I'm going to hand over to Sven, who will start to discuss some of these in a little bit more detail. Thank you.
At least one of the little areas. So as Steve just mentioned, condition-based monitoring and actually real predictive maintenance requires this real-time data or near real-time data. But what does that actually mean? It's a term we use a lot. We need to have lots of data. We need to have lots of real-time data. But the aim is really to collect, ingest, and store data in such a way that it will support the analytical models that we choose in a way that underpins the outcomes from a condition-based monitoring or predictive maintenance activity. And whilst that actually sounds easy, and really it is in many ways, my suggestion is to really start simple. It's this idea of starting to flow data from the sensors within an asset or the telemetry data that an asset is giving off, and ingest that into a data platform, and then start to apply simple things such as a rule-based threshold to start getting a feel for what that asset is sending through. What is that data? What does it look like? And my experience is that when we do this, we actually often get surprised that the data that we believe the asset is sending is not actually what it sends through. It's not consistent. It's slightly out of alignment from a date point of view or a timestamp point of view, or the timestamps get manipulated, or there are a whole myriad of different things that happen along that transport from the sensor through to the platform. So this idea that we know exactly what's happening is put to one side, or we really have to start looking at that. So once we have a good picture of what the data is that the asset is sending through, we need to then start looking at how does that data help us when we want to apply more sophisticated models. And this is where we start to look at, well, is the data source relevant to what we want to do? Is it valid? Is it clean? Is it consistent? A lot of the time I see data coming through that's very inconsistent, and that often can cause problems. And also, and this is probably the most important aspect, is does that data or does this outcome support what the business is looking for? Are we just doing this because it sounds good? We want to do some form of predictive failure or predictive maintenance, whatever that predictive buzzword is, but does it support the business? And if it doesn't support a business outcome, why are we collecting the data? So I've already said that we're looking at getting that data from the sensors. We want to actually understand whether it's clean and valid. But then once we have that data, we can then start to apply statistical methods, maybe in the first instance, to understand whether there are any signals or patterns or trends that can start to indicate the condition of that asset. And that's important because that gives us that first step. That gives us the confidence that the signals or the patterns that we're seeing in the data really have some meaning in this exercise. And then once we have that, we can then build upon that. We can then put some more predictive models on top in order to drive towards that goal of having a predictive maintenance regime. But as Steve has already mentioned, the importance here isn't to just go for a straightforward, everything out there into the prescriptive maintenance world. It's important to develop a hybrid maintenance regime. And whilst we can start to apply, we can use lots of buzzwords, whether it's supervised, unsupervised, statistical, or whatever function, methods, whatever algorithm we want to look at, we have to be selective. It's not a case of just taking a single method or a single approach and applying it to all asset classes. And then once we've done that, once we've looked at that, we need to really work out as to whether assets are going to benefit from real-time condition monitoring. I mean, if we look at a production line workstation, for instance, or a railway rolling stock, they're not equal, and therefore this concept of real-time needs to change, needs to be different, and so that needs to be factored in here. And then lastly, I would also argue that whilst all asset classes really benefit from real-time alerting to give their current state, it really is unrealistic to apply a predictive model, for instance, to an asset that takes a decade to fail. I mean, it's a great idea. I mean, for people like me, it's a fantastic opportunity to get involved with big, heavy industrial assets, but really, it doesn't make sense. So really, the takeaway from this chart is the importance of having a consistent, reliable, yes, repeatable and relevant data source upon which to build, and that's the takeaway. If we don't have that foundation, then everything else that we talk about in predictive maintenance or condition-based maintenance really falls apart. And Sana, take it away for the next bit.
Thank you. So I'm going to talk a little bit more about the technology of machine learning itself and some of the use cases where we have deployed this with our customers in the past. And I'm also going to touch a little bit about the methodology that we use when we work with customers around this particular topic. So at the heart of what I'm talking about is machine learning, which is a subset of AI. We call it machine learning, predictive analytics. It's essentially where we have a specific problem that we're trying to solve. We're trying to predict something happening for that problem, an event. And we can take historical data where this particular event is known, such as a failure, for example, and we then use machine learning models to uncover patterns in that historical data that drive that particular outcome. And once we've done this and trained the model, we can use that then for live data coming in to alert us when the likelihood of an outcome occurring is high. At the heart of these are all different type of scenarios, but IBM works across industry, and machine learning is everywhere in society today. So if you look at banks, they use it to predict risk in lending money to a person. Insurance companies use it to predict fraudulent claims. Police use it to predict where crimes are going to occur. Netflix even use it to predict what series we're going to binge watch next. And IBM works across all of those industries, but we also work across asset-intensive industries. And on the screen now are some of the customer success stories we've had over the years. We've been in this field for many, many years. And there's two examples in here I quite like. The one in the bottom right corner, which is the sewer lid. This is one of the first projects my team worked on, and I think it's probably going back maybe 12, 13 years. So this was around predicting sewer leaks. The other one I want to contrast this with is on the left-hand side, which is the jet engine. So this is Pratt & Whitney. They are an aviation company. They make jet engines for civil and for the military sector. They were interested in predicting in-air shutdowns of engines, obviously something that is quite critical. So two very different scenarios, but both focused around some kind of failure. And we applied machine learning to both of them. But the interesting thing about this is to look at the data, because if machine learning is at the heart of this, data is the fuel for machine learning. And data is a big conversation that we have with every customer about, do I have the right data, etc. I'm going to touch a little bit more about that in the next slide. But for the sewage company, it's very difficult to get data, especially going back 12, 15 years, where the sensors were not as prevalent as they are now. A lot of water companies are made up of lots of smaller water companies. Historically, records may be incomplete or inaccurate. They don't really have that much information in some cases about what assets are actually underground. What are the pipes? What's the quality of the pipes? You know, if they're cast iron, are they post-war cast iron? What's the quality of the iron, etc. So it's kind of a tricky one because you don't have that much data. So for that, we had to look at things like topography, the number of residents, restaurants in the area, fat deposits into the sewage, rainfall, etc. So we had to work around kind of the traditional data that you perhaps would look at for an asset. On the flip side, if you look at a jet engine that generates something like 1 terabyte of data per hour in flight, you know, we had vast amount of data. But the important thing here is you don't actually need that much data. I think in the end, for the model that we used, I think we used something like 20 variables out of all those thousands of variables. And that's the beauty of machine learning, is that we work with your engineers and take your institutional knowledge to start bringing the data in, but then our model will actually tell us which variables or features of that data are important. So which ones are actually driving this particular outcome. So that's when we kind of start bringing the sensors down, and we don't need to sensor everything up or bring all the data in. We're just going to bring the data in that is important. So the methodology we use, we've been using this methodology for about 25 odd years. There are some different variations on it, but this is the way I normally explain it to customers. So this is, if we come out and do a workshop with you, how we would approach it. And we always start with the business understanding. So this is where we're trying to understand what is the problem you're having. And we don't want this to be too general. So we don't just want it to be, oh, I want to increase productivity or reduce downtime across all my assets. We want it to be quite focused on a cohort of assets or on a critical asset. You may have something on your production line that you don't have failover for, and there's only one. And if that particular asset goes down, then you know your production line goes down. And you don't just have to come up with one use case. When we do these workshops, we normally end up with a number of use cases that we will then take forward and look at the suitability for. The other important thing around here is to try and estimate the cost. So how much is this problem costing you? Because this is important when you go forward to evaluate if this was a success or not. You know, are you actually having the impact on the business where you're getting this money back? So this is something you can start thinking about today. You know, look at your operations. Do you have any problems? Do you have any problem assets? Anything that's critical? Anything that's costing you? So that's something you can start off immediately, and we can certainly help you with that. The next step is the analytic approach. That's up to our data scientists. They will look at, for this particular problem, you know, what's the best way of solving it? Do we do an anomaly detection? Do we predict time to failure? Do we do root cause? We have many different options here depending on the problem. After that, we talk about data requirements. So this is when we, for each of these problem sets, understand from your engineers, you know, what do they think is actually driving these failures? Do you have any data for that? Do you have any historical data for that? Can we actually capture more data for that? So this is the whole discussion around data. From there, we go on to collect data, and the data scientists will then do some data understanding and data preparation. Actually, 80% of one of these jobs often is in this area. It's around getting that data into a shape that's suitable for the modeling part. So when we come to the modeling part, this is when we take historical data where the outcome is known. So let's say we're looking at predicting failure. So we will have, let's say, sensor data for a particular asset. We have the failure code, whether or not it's failed. We take 70% of that data and we train the model. The model will go in and determine which patterns are present when these failure modes happen. Once we've trained it and we're happy with it, we need to test it to make sure that the accuracy is correct. So we take the remaining 30% of data where we know the outcome and we run that through the model, and we will then compare the actual outcome that happened historically with what the model predicted had happened. And that's how we get our accuracy. At this point, we may end up going back to get more data because we may go, actually, that's not accurate enough, or we're not answering the question. So we could be in this kind of data requirements, data collection stage for a little bit iteratively until the model is accurate enough for our particular business problem. After that, we go on to deploy this into your operation. So this is where we embed analytics into your operation. And obviously, we'll continue listening to the results of that model to ensure that the accuracy remains high or remains at the level that we want. Okay, so that was the methodology we use. So this was a quick introductory session to some of the maintenance strategies we have and some of the machine learning technologies we use, but we're going to run a number of these sessions in the near future. We're going to talk a bit more about Maximo, but we're also going to talk about how we can use Maximo Health and Predict to get more insight into your assets. We also have a monitor tool that allows you to monitor assets at scale. And we have Maximo Assist, which is a expert knowledge system that we'll also cover in one of these upcoming sessions.
Thanks, guys, for the presentation. Very, very interesting. Quick one. Yeah, there's obviously a great suite of products there, which obviously come at a cost. And then you also talked about the fact, are you sure you understand what that data is that's coming through? And obviously that is defined by types of sensors you put on your devices. So the question really is, do you offer a sort of like a proof of concept, proof of value service where you can just come in and pinpoint an area and work with the customer, and you just deploy the suite for a period of time to then come up with a view of how you would do that on a larger scale?
So I can answer from a machine learning point of view how we historically work. It really depends on the type of problem that we are trying to prove out. So if you are new to machine learning and you haven't seen machine learning in action, we could look at some historical data that you may already have around the problem, and then do a small proof of modeling exercise around that, where we can show you how we can predict or get insight into a specific asset. The reason I spoke about machine learning in general is because we have machine learning at different levels in these different tools, and until we speak to a customer to really understand the problem they're trying to solve, it's hard for us to say this is the tool you should use. But we'd rather go in and speak about the problem and then advise that, you know, this is the tool you should use. And from there, we need to work out what is the proof point you need. You know, is it that we can monitor vast amounts of assets, or is it that we can investigate your data, or is it that we can put sensors on? From there, we would then move on and do that type of pilot project. Did that answer your question?
Yeah, partially. Yeah, absolutely. It's all about understanding the problem.
It is understanding the problem, but it's also not about deploying all the tool set. So the question you asked was whether we do POCs, and the answer is yes. And we come with either one or two of the solutions that we talked through. The idea is not to come and drown you in technology. I mean, that's quite easy to do, but that's actually not really the point. So yes, this idea of coming and exploring what do you have, it's not always necessary to add more sensors. I think out of all the client engagements that I've worked on, I've always tried to avoid recommending clients put more sensors on an asset. It's more to do with what data do we have, as Sana says. Can we get hold of it? Can we extract it? Can we process it? Can we store it? What does it actually look like? Does it feel like the kind of data that we can use? So that's at one level. The other level that I'm finding quite useful at the moment is the flowing the data. This idea of, yes, I've got a control system out there. Doesn't really matter what it is. Say it's just a control system. Call it a generic thing. So I'm able to extract the data. I'm able to flow the data, and that's where this whole idea of being able to pick it up, ingest it, and store it. So it's a very useful technique to just see the data flowing into a database. So it comes off the control system in one standard, or as it might be, I don't know. It might come up off the controller as a I've just completely, I had the standard in my head and it's just completely gone out of my head. Oh, never mind. I can't remember what it is. But anyway, let's say it comes off the sensors. Let's call it a proprietary standard. How do we convert that into something that's more industry, so that more tools can actually, in fact, make use of it? Let's say we convert it into JSON over an MQTT protocol. We then store that data into an SQL database and then extract it. Even that in itself is a very useful exercise. It just gives us the confidence that we can extract the data. It goes to what Sana was then saying is, once we understand that data, does it actually support something like a predictive maintenance activity? Could it actually do that? And that's part of the activity we can help you with, is come in and have a chat about that and explore the data, as Sana says, but also sit down with some technology, take the data, flow it through into the platform, the ingestion platform, see the data in situ, apply some functions and see whether that's already the start of the 10. If it isn't, then we work through with you. Maybe it is a case of applying some sensors, or it might be a case that we start to look at what do we do at the edge? Do we apply some rules, some enrichment rules, or some algorithms at that level, so that we convert the data into something that's a bit more useful to us and then flow that through? Or it could be that we need to then start looking at other data sources and bring that in, because data is something that a lot of companies have. So we then do some more enrichment, let's say at rest. So once we've ingested the data and put it into a database, we then do some more enrichment. So we can do that. So that's without having to go in and install the whole product suite. We can become very selective and take those components that really are needed. In this case, exploring the data is ingest and then analyzing. That's really the two that we would use, the two solution sets that we talked about.
Thank you.